G'day chemistry students. In this video we're looking at two sets of dot points, one from module 5, 5.3.4, as well as 8.1.4. We're going to be building on our understanding of colorimetry and making calibration curves to find concentrations of contaminants in environmental samples. But in particular, we're going to be building our skills in colorimetry, but instead of finding concentrations of substances in an environmental sample, we're instead going to be looking at trying to find the concentration of a solution equilibria, in particular an equilibria that forms a really interesting substance called iron thiocyanate. Let's get into it. So first off, just looking at the module 5 syllabus, we do need to investigate the equilibrium of iron thiocyanate and how we can change the concentration of ions. This is something that we did in module 5, but the thing that becomes really tricky is that we needed to also conduct an investigation to find the KEQ of a chemical equilibrium system. So the example that they give is to do an iron thiocyanate equilibrium. Challenge is trying to determine the equilibrium constant of a chemical system is really, really tricky. To find KEQ, you need the concentrations of all substances. Usually when we were doing calculations in class, we were given a bunch of data. We never had to take those measurements. I'm sure that we can appreciate, since doing module 5, the techniques that we've been using to determine the concentrations of substances are quite involved. And that was not a set of skills that we had during module 5, so it was skipped, and hopefully we can use some colorimetry techniques now to be able to find the concentrations of different substances in an equilibrium, and then use those concentrations to be able to calculate KEQ. So first off, to calculate the equilibrium constant for this iron thiocyanate equilibrium, we need to be aware of the actual equilibrium reaction itself, as well as the KEQ equation. So to make iron thiocyanate, which is blood red in color, we need a substance that has iron 3 ions, as well as a substance which has thiocyanate ions as well. That leads to this KEQ expression. So to be able to find KEQ, we need the concentrations of iron thiocyanate, iron, and thiocyanate ions as well. So what we need to do first is make 5 reference solutions. These solutions are going to have set known concentrations and will be used to make our calibration curve. So in each of these, we put in different volumes of iron nitrate solution, iron 3 nitrate in particular, and potassium thiocyanate solution. Something to note is that the concentration of the iron nitrate is significantly larger than the potassium thiocyanate solution. Reason being that if we add a whole lot of iron nitrate to potassium thiocyanate, regardless of the ratios of volumes that we have here, we're expecting to see an extremely large excess of iron nitrate. And even though some of the thiocyanate ions will end up consuming some of the iron ions, what we should find is that because of the difference in concentration, a negligible amount of iron will be consumed, meaning that whatever the concentration of iron was at the beginning, before this equilibrium process went through, we can sort of assume that the concentration of iron will remain constant, meaning that we can take an absorbance of whatever's going on up here, as well as still have a rough idea of what the concentration of the iron in the solution is, because we already know its starting concentration. We can take in a dilution factor and then assume that essentially a negligible amount of it has been consumed, meaning that the concentration stays the same even though a reaction has happened. What we then do is make a test solution. So what we'll do is combine iron and thiocyanate ions of matching concentrations, allow them to reach equilibrium, and then take an absorbance for that one. If we know the absorbance, then we know what the concentration of iron is based on a calibration curve. And if we know the concentration of iron, we can end up actually using an ice table to determine the concentrations of all of our other substances. Once we know the equilibrium concentrations of the other substances, we can go back and substitute all of that information into our KEQ equation to produce our KEQ value. Again, some of these concepts might be a little bit tricky. There's a fair few assumptions that we're running with, and the math may not make a lot of sense until we actually get into the room and start doing it. But hopefully, with the information that you've got at the moment, you've got a rough idea of what we're going for. Main idea, make a reference solution first, take all those measurements and do a calibration curve. Following that, we can do a few test solutions to try and figure out the equilibrium concentration of iron and thus thiocyanate and iron thiocyanate, and calculate a KEQ value. So we're hoping to produce something similar to this, a calibration curve, and again, using those test solutions, being able to find an absorbance and figure out what the concentration is from that. Thank you very much, everyone. In the next video, we're going to be looking at conducting an experiment which requires us to undertake gravimetric analysis, a slightly different analytical technique and one that you're probably most familiar with. And we'll also be focusing on the concepts of yield and purity in that experiment too. But until then, have a good one.